Glad you're here. I'm Jen Lepore, Marketing Team Coordinator at Custom Processing Services, and today our Director of Engineering, Carl Fiorini, and I are going to talk a little bit about powder processing and electric vehicle battery production. So, right now, the global electric vehicle market is exploding. Somewhere close to 4.5 million EVs were sold so far in 2024 alone. That's clearly pushing up the demand for EV batteries and creating a substantial need for powder processing. And well, that's where toll processors come into play. So, with that being said, Carl, would you briefly describe how a lithium ion EV battery is set up?
Sure. So lithium ion is, currently the buzzword within the battery industry. It's really still in its infancy stages here as it's continuing to find different opportunities of, material components and everything that's really impacting the optimization of the batteries. In a high level oversight, it's no different than the batteries we're working with every day. There's the positive cathode side, the negative anode side. There's separator materials within it. The main difference is, how those are layered within the battery cells, but also the materials that are used within those cathodes and anodes. That's where you start getting into, some different lithium-based materials, different graphites and silicone possibilities. So that's really where you're finding the advantage within lithium ion in greater energy density. So you're able to hold a higher charge within a smaller amount of product, a longer battery life where you don't lose as much of your charge efficiency as you repeatedly charge it, as well as a lightweight option because using less product is typically not quite as beefy as some of the historical, battery cells that we've been used to.
Okay, so what would you say some advantages of toll processors in this market is?
One of the advantages is we are able to handle a lot of the different materials that go into the lithium ion. So when you start with the cathodes, you get into your lithium iron phosphates, which are products that are typically going to need to be milled down to a consistent powder. You have the graphite or silicone potentials on your anode materials, which is going to be applied in a layering capacity on maybe a copper foil. You get into your pure lithium materials, which has a better energy density compared to what graphite and silicone may provide, but also is moisture sensitive. So, finding the right toll processor where you have those humidity controls to keep the quality of product at a high level is also very important.
Okay, so why do you think EV battery suppliers need such a uniform material type powder?
So it's all within the application. The material is some of that energy density that you're gaining out of it is really gained through the density, the compaction density of the product. So as you get into these smaller particle sizes, you're able to layer more product on. The spherical shape that you may get out of it helps within that, eliminating the void. When you're talking about layering something, it needs to be layered in an even coating so there isn't air or moisture potential within the battery cell.
So would you say there is a standard minimum particle size that the suppliers target for lithium ion batteries?
So we haven't necessarily seen a standard minimum size. It does really depend because each of those components within the battery are so unique. It really does depend, which application you're looking at. Something like one of the graphite coatings may be a 70 micron thickness. So they're having a 5 to 10 micron powder where you're able to consistently apply that and have a smooth coating function is really important. Whereas the separators, which, are typically overlooked in it, are very important components, separating your cathode and anode material. Those may be a ceramic based product that maybe doesn't need to go quite as fine. It's really providing that physical barrier where you can still get the charge flow, but keeping the physical separation between your positive and negative. So, again, one of the advantages of the toll processors are with the wide variety of equipment, someone like CPS has, you can start to find the right process for the application you're going for. Whether it's a humidity control on a lithium base, it's a jet milling on a lithium iron phosphate, or even if it's a mechanical milling option to keep a product a little bit coarser.
Okay, so would you say particle shape does matter then?
Yeah, particle shape and purity both matter. Typically we try to stay away from the mechanical milling as much as possible because you do run the risk of some shear type forces as well as wear that can maybe add a little bit of the impurities to the products, creating a more spherical, uniform type particle shape within something like a jet milling or even a wet media milling application can really help within that packing to reduce any void space. So it comes into the surface area as far as the functionality of the product, but also the density of when you're applying it.
Now, let's talk a little bit about the processing side. So, what type of equipment is typically used for processing EV materials?
Dry milling is certainly a common option. That's what people are most familiar with. It seems mechanical milling is usually one of the first questions we get asked. It can tend to be a cheaper operating cost type of mill. Again, one of the concerns with that could be any impurities that it picks up because of the mechanical impact. We also look at a lot of jet milling where you can create particle on particle collision. So there, instead of using an external, impact force or shearing force, you're using particles to start breaking them up. I always try to describe, imagine two bowling balls being thrown at each other. They're not going to pick up any impurities, but they're going to shatter. And that's really what's happening on a jet mill application. So you get a very pure product at a very consistent particle size. And then we've also seen the wet milling, the media milling applications and dispersions becoming a higher inquiry because that type of technology will allow you to get into the nano size. Your original question of what's a common particle size, I believe that's still being developed within the industry because the smaller and smaller you can drive it, typically that's a higher and higher surface area, which is only going back to some of those advantages we started with of energy density and charge capacity. Within the media milling applications, you can now get to the nano size, working at average particle sizes of less than a micron that just dry mechanical or jet milling can't reach. It does play into some complexities then because typically you're working with a slurry application, but sometimes a slurry can be used as is within the next step, such as a coating application or something like that.
Okay, so would you say there is a preferred processing method?
At this time, I don't know about preferred. I mean, I believe it's really material and application dependent. Um, I believe the common preference we're working with is the purity level within these battery materials. So I would say materials of construction seem to play a bigger part in what technology we're selecting. Having some type of abrasive resistant milling technology, so you're not picking up those impurities, is probably the most important, one of the more important, qualifying questions with our customers.
What kind of determines the equipment and the methods used?
It'll typically be within the particle size range that our customers are looking for. So the application of a 5 to 10 micron product is going to have a lot of options within the dry milling side. Anything that's getting to hundreds of microns, maybe you start opening up that library, that catalog of equipment to see what else is out there. Once you get into the sub micron, as soon as that becomes a driving question for us, that's where we start looking at the media side. So when you're looking at it, it's materials of construction, as I stated, as well as the particle size. The last thing to really take into account too is going to be the environmental conditions of the processing base. So as you're working with something that's very moisture sensitive, like a pure lithium, that's going to need to be in even more than just an HVAC room. It's going to probably need to be in a dry room where you're keeping the moisture level incredibly low, so it doesn't pick up anything, ambiently.
So, why would you say maximizing yield is so important?
Well, maximizing yield, obviously, as we're getting into higher quality products and, all those advantages you gain typically comes with the supply costs, right? So getting into some of these materials like your LFPs and lithiums and even your graphites, are typically a higher cost raw material. So it's always important that they want to maximize the yield so there's not as much, supply loss, held up within the processing chain.
Okay, so would you say a toll processor have to have specialized materials knowledge?
But yeah, so every material is unique in how it's handled. We like to joke that's usually the milling side can be the easier challenge for us. It's how do we feed these different products? Everything likes to flow differently. Everyone likes to be conveyed differently, and how do you collect them in a clean manner? I mean, it's at the end of the day making a granule powder, a granule material, and making it into a powder, and it's dusty. So, how do you set up a dust tight operation? And that's really being able to have a lot of experience with a variety of different materials gives you the advantage to understand how something might behave so we can anticipate those problems, maintain the high yield, and get the quality product out the door.
So would you say there are any types of concerns over material reactivity, especially when handling lithium?
Well, with lithium specifically, we do have the moisture concern. It does like to absorb moisture, which ruins pretty much the quality of the product, the functionality of the product within a battery cell. Within some of the other components, there's always the employee safety, the process safety. That's paramount. So, doing a detailed safety review and understanding the proper PPE and engineering controls that go into the processing bays to make sure we're protecting our staff, we're protecting the environment, so we're not expelling any dust with emissions. That's all one of the first levels of review when looking at these projects is not necessarily only the reactivity, but the safety and environmental impacts as well to make sure we have the right protocols in place to protect everyone.
With that being said, I know CPS has a dry box. So how does the dry box that we have on site help mitigate handling risk?
So the dry box gives us the opportunity to run to the ppm level of oxygen or moisture in the environment. We selected this unit because of the size of it, so it allows us to work with extremely moisture sensitive products like the lithium in a small lab level. We can put in some of our testing equipment to do analysis. We can even put in very, very small spiral jet mills that'll mill products in the grams or even maybe a kg or two quantity with nitrogen. So we're able to kind of get our hands on some of these moisture or even, materials that may be a little bit more combustible that need to have an inert environment where you're minimizing the oxygen in the dry box. So within those two functionalities, it's really expanding our ability to handle either, hazardous or sensitive products at a lab scale. We have rooms that are currently air conditioned that are looking to be retrofitted into a dry room environment. But this has been the first opportunity for us to really look at things on the lab level.
Talking about a little bit of trends and in the future type things. So, we focused on lithium ion EV batteries today, and because they're the most common. But other technologies are starting to show up, solid state and sodium ion and zinc based. And I think I actually even read that some scientists testing sand and seaweed alternatives. So, how would you say that CPS is kind of preparing for the future industry changes right now?
So one of the advantages to CPS's business model has been the wide variety of technologies that we keep on site. So as every product, even the material on the material handling side is going to be unique. We've had enough of the variety and customized setups that we're able to quickly adapt to whatever may be next in the door. When you talk about something like seaweed, is that something that needs an additional moisture level and maybe a coarse chopping application before you get into a fine grinding? So we've been able to expand our grinding applications to really handle the whole spectrum, up to bricks of material all the way down to the slurries of nano sizes. But we've also outfitted ourselves with enough supporting technologies such as classification and drying and blending that there's material prep work usually done before you're just doing a particle size reduction. So those different types of technologies that we have on site really allow us to have a larger arm in the supply chain, from handling everything in the initial, after source all the way to the final application.
Obviously, we can't talk about the future without mentioning sustainability. So, how would you say CPS helps reduce the waste and support sustainable EV production? And what do you see on the horizon?
So we have a unique role within the supply chain. Obviously, we're not sourcing materials or manufacturing necessarily the final, shelf item. We are the materials and ingredient processors. So one of the biggest impacts we really focus on is our yields. Obviously, yield is, financially supply chain waste. But also it plays into then disposal considerations that we want to minimize our impact to the disposal world. So trying to maintain the extremely high yields where we can typically boast, 99% plus yields out of some of our processing equipment is really a point of pride for ourselves to make sure we're accounting for everything in the door is also going out the door in a functional state. A lot of the materials, can be, sometimes tricky in the disposal consideration. So anything that we can do to minimize that has been really important to us. We also look into the environmental concerns as well. As I was saying earlier, we look at our emissions and, how do we make sure we can have the best collector filters in our systems that we are collecting everything that we are milling. That's a very important aspect for us as well. So not only are we minimizing disposals within landfills or the incinerators, we're also keeping the air quality clean.
Well, you definitely gave us a lot of insight, and we do appreciate that and appreciate you stopping by. And thanks everyone for watching this month's Custom Processing Services Toll Manufacturing Minute. Be sure to subscribe to our blog to get the latest episodes of our show, some news, insights from our experts like Carl, and we'll catch you next time.
Thanks for having me.
And